here's an example of a piecewise function. Okay? And this is saying, and you read these from left to right, and this is going to be one of the really hard parts about doing this, is you're not used to doing that. So when you read a graph, it's like reading a book. You're reading stuff in this direction. Okay? So if I'm actually going to read a book and see what happens first, I'm going to go like this. Oh, this is happening first. Okay? So if I'm reading this, this is my guideline to know when this is happening. Okay? I'm going to relate time to my x value right here. And I can see if I take this apart, I'm going to assume this is counting by ones. This is when x is -1. Do you see that? Mm-hmm. So I can tell you when x is -1, this is happening. Okay? Now I'm going to stop reading this one and I'm going to keep reading. Oh. When x is greater than -1, this stuff is happening. When x is less than -1, this stuff is happening. And when x is greater than -1, this stuff is happening. So what I have here is a function that's happening, two different things are happening at the same time. One thing that's happening is this. And remember, that's the same thing as y equals x minus 2. That's just a linear function, okay? Fancy label. And this is also happening. F of x is x plus 3. Or y is x plus 3. So I have two lines going on at once. Okay? One of the lines was this whole line right here. This was a whole line. But it was only happening when x was greater than 1. So I didn't copy this part down. And this was another whole entire line. But just like that income tax chart, it only happened at a certain interval. It only happened when x was less than -1. So can you read the graph?
Yeah.
I mean, you understand what I just told you? Somewhat. Okay.
Why is one of them colored in?
Good. That's a good question. And the reason one's colored in and one's not involves these signs right here. If it has a line under it, an equal sign under it, it'll be colored in. And if it doesn't, it'll be open. Okay? The way to say that two things are happening at once is to put it in a notation like this. A piecewise function. You have one function, but different things are happening at different times. Okay? So, your job, this is not supposed to be done for us. This is our example. This would be the problem in your book. The problem in your book would say, graph this, and identify the domain and range. So how do we even go about graphing this?
Well, you know that you're...
Okay.
You could put it into slope-intercept.
It's in slope-intercept form right now.
Okay.
So how would I go about graphing that?
Well,
it's going to be on the cross -2.
It's going to cross at -2, right? So I'd go up here and I'd make a dot at -2. Oh, -2.
that's
And then what is my slope?
1.
My slope is 1 over 1, isn't it? So that means I'm going to go up 1 and to the right 1, right?
Okay, how do we know that was our slope?
Because we're in slope-intercept form, and that's our slope.
Your answer is
I know that x minus 2 is the same thing as 1x minus 2. So my slope is 1.
Well, how did we... Oh, okay.
Okay? My slope is 1. So that means I'm going to rise 1 to up and run to the right 1. Rise 1, run to the right 1. Rise 1, run to the right 1. Okay? And I really, at this point, would only have dots on this graph. I wouldn't connect my dots with a line yet. Until I go back and I check, oh, where is this true? This is only true when x is less than -1. Okay? So remember, I'm reading this from left to right. I see my dots. I know where they are. But this is only true when x is less than -1. I know it's an open because it tells me that right there. It's just like the income tax chart. This is only true when this is occurring.
Do you have to go to the...
You have to go on the x-axis to that number. Okay? You have to go on the x-axis to that number. Find your graph on that number, which would be right here. Right? And where are the things that are less than -1? They're this way. So this is my line, so I'd make an open circle and I would say, okay, it goes down like that. That's where it is. Even though the rest of this exists, it's invisible. Okay? Then you go to your other one. Where do I start graphing this?
At the intercept of +3.
Of 3. 1, 2, 3. There it is right there. How do I know what my slope is? It's 1 over 1. I go up 1 over 1, up 1 over 1. I got a little line. Yep, yep, yep. There's the whole line. But wait. It's only happening when x is greater than or equal to -1. So you find your -1 on your x-axis. Greater than is everything to the right of that. So here it is. That's the only piece I want. It's filled in because of that equal sign right there.
Okay, I have a question.
Yep.
This might just be like a weird graph or whatever, but on the first, like the little line part that's on the bottom is like where it starts is down.
Yeah.
-3, and the other one where it starts is up +2. If you look at your two numbers that it gave you, like for your intercepts or whatever, those are like the opposites. Like
Probably for this you'd be all right because there's nothing in front of your x. Okay, I wouldn't. The reason is I'm not even gonna go there. Okay.
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 But
So
is that gonna be that way in all of them, or is this just a weird one?
you check that out for me, okay,
Okay.
Alex? As we go through this, you check that out for me.
So what happened?
Okay? He noticed that this dot, the reason this dot is there, I can tell you right now, is because they put in this equation right here, they put in -1 right here. Did the math and got this. So their first point was going to be at -1, -3. So you can figure out your point that way.
But yeah, but it comes from the other part of the thing.
Yes, it did, but this is a real simple equation.
Oh,
You know,
right.
if it was something else, you weren't going to be able to figure that out.
Okay.
Okay? So yes, you can figure that out. All right? So we graphed them. Now it said we had to find the domain and range. So your domain is the wideness of your graph.
Infinite.
It's infinite to the left, and it's infinite to the right. Are there any gaps in the middle where a graph does not exist?
No.
No, even a graph exists right here, but only right there.
So will they have to like put that both of them are like when it's a greater than or less than signs on the other side of those where it says -1? Will those always have to be the same number?
What do you mean? Like over here?
Yeah,
Will that always be the same number as what?
as the one like above it or below it. Like.
Oh, right here and here?
Yeah.
Absolutely not. No.
Okay.
What about our range? Our range is the tallness of the graph.
All real numbers.
Is it infinitely tall?
Yeah.
Is it infinitely below?
Yeah.
Is there a gap in between where no graph exists?
Yes.
No. Yes.
Yes, there is a gap in here where no graph is existing. Okay? So I do have to limit my range. It's not all real numbers. I do not have a graph between these 2 points, do I? Okay? So what I can do is say my range is higher than this, and my range is lower than this, and that'll satisfy everything else. Okay? So I would say this is how you would do it in correct notation. You would go the set of all f of x such that f of x is greater than or equal to, my positive numbers are here. What is this number right here? Because this is the number I'm concerned about.
It's 2.
It's 2, right? So greater than or equal to 2. Or f of x.
Isn't that just greater than?
No, because that dot's filled in.
Oh, yeah.
Or
Less
f of x
than
is
or equal
less
to-
than, what is this number? Negative 3. That's how you would say. That's what your range is.
Wouldn't it be and though instead of or?
That's technical. I don't care. Okay, I don't care which one you put.
Okay.
Okay. So let's try one. Here's our function, and different things are happening at different intervals here. Okay? Now, we can go with what Alex said, and that might be kind of fun. So let's try it. Let's take this first equation, which I'm going to rewrite as y equals x plus 2. Does anybody have a problem with that? Y equals x plus 2. And I'm going to put 0 in for my x. Okay? Put 0 in for my x. So if I put 0 in here, that means I get 0 plus 2. So what is 0 plus 2? 2. So the point is, now I did f of 0 and I got 2. That's like you made a prediction. You know what I'm talking about? F of 0, 2. So the point is 0, 2, where my graph is going to start. Okay? So I'm going to go up here to 0, 2. And I'm going to notice that this is a less than, so that's just going to be an open circle. Okay? So where is the line? Well, the line has a slope of what?
1 over 1.
1 over 1. So this stuff is happening less than 0, though. So this stuff is happening over here. So if I go 1 over 1, 1 over 1, 1 over 1, I'm not going to get anywhere.
Right, you're going to go
So I should go
negative 1 over negative
down 1, negative 1, down 1, negative 1, down 1, negative 1. And I'm only going to start it right here. And I'm going to be very accurate. This should hit every corner. A slope of negative 1 should hit every corner as I go out of here.
Yeah. Because that's C right here x. Before x is your
Well,
slope. And since
what
there's
I'm
nothing
curious
there,
of
it's
is-
understood to be 1. Right?
So
So
you
that would be 1 over 1 because 1 over 1
use
equals 1. Right?
the 0 or whatever number they
So
give
then
you
your
on
slope
the
is 1
side
over 1,
as your
which
x
is the same
number.
as negative
Yes.
1 over negative
Okay, that's where I
That's
got
what we're
lost
doing.
when we were trying to
negative 1, negative
point
1,
that.
negative 1, negative 1, negative 1, negative 1.
Okay, we got to graph the other piece now. The other piece is f of x equals x. That's interesting. So it tells me to put in 0 for this one too. So f of 0 means I'm going to put a 0 in right here. So what would I get?
0.
I would get 0, right? So my other start is going to be at 0, 0. And I need to fill that in because it's greater than or equal to. What's your slope of this line?
1, 1.
1 over 1. Which way am I going?
Positive.
And
I'm
over,
going,
up and over.
be careful, I'm going right here. What does it say?
Greater than.
Greater than,
Or
so I'm
equal
over
to.
here. I'm going everywhere on my x-axis that's greater than. So I'm going to go 1 over 1, 1 over 1, 1 over 1. You got your pattern. Make sure you hit every corner. Yes.
If I came towards the end of this period, are you going to go right to the end of the period, or I got to talk to you?
Me?
Yeah.
Okay, yeah.
Okay.
Yeah.
Okay.
We can work something out.
Or what do you have next period?
You could do it like the beginning and next
Okay,
period would be
I'll
good.
come up there.
That'd be great. Thanks. Okay, so there's your piecewise function. Okay?
Wouldn't there be a line connecting both dots? Because if you put those two things in, it shoots from one to the other.
Are you talking about right here?
Yes.
No, because this tells me, this is a function, first of all. If you do the vertical line test on here, this is a function because where do I touch the graph? Not here, because that's an open circle. That is not a graph. It only touches it right here. So that tells me at 0,
It's a function.
I get 0. That's it. If I go anything less than 0, I'm going to be here. And if I go anything greater than 0, I'm going to be here. Or equal to 0. What's my domain?
All real numbers.
The wideness. Am I infinitely to the left?
Yes.
Am I infinitely to the right?
Yes.
Do I have any gaps in the middle?
No.
No. I'm all real numbers.
What was the
What do you mean
horizontal
gaps
line
in
test
the middle?
Like up here, Natalie, when I was doing this one, it didn't have any gaps this way, but it had gaps this way. If I, between my hands, there is no graph. That's a gap. This graph only exists from here on up.
Oh, okay.
And this graph only exists from here on down. It doesn't exist anywhere in here. Okay?
What was the horizontal line test for?
If it was 1 to 1. Okay? All right. So now I do my up and down. Am I infinitely high?
No. Yes.
Am I infinitely low?
Yes.
Do I have any gaps?
No.
If I start closing, do I have any gaps? There's a graph all the time, isn't there?
Yep.
So what is my range? All real numbers.
And so that wouldn't be 1 to 1 then, right?
No, it's not 1 to 1. Because
Wait.
at 1, y is either...
Oh, there's no graphs
I
because
shouldn't say that.
at,
Yes, when y is 1, x is either -1 or 1. See, so I'm kind of confused there.
oh, okay. So that's why there's no graphs is because they kind of run beside each other.
What do you mean there's no graphs?
Or gaps.
Yes, there's no gaps because if I'm looking at this function, can you see a graph?
Yes.
Can you see a graph?
Mm-hmm.
Can you see a graph?
Yes.
I'm looking for a place that you cannot see a graph. Can you see a graph?
Yeah.
Can you see a graph? You can see a graph. That's why there's no gaps.
Oh, okay.
Up here, you could see a graph. You could see a graph. You could still see a graph if I was right here, couldn't you?
Yeah.
But if you look right in between here, you can't see a graph. That's a gap.
Okay.
There's no graph there. That means for these values of y, this cannot exist. That should seem weird to you. Let me show you something off the subject for just a minute. I want to show you a function that might help you understand that just a little bit better. If I had a function, well, you know this isn't going to be a function because it can't have an x on the bottom, but let's pretend it's a relation anyway, and I want to graph it. 3 over x minus 4. All right? That's a relation. It's not a function because the x can't be on the bottom, right? Not a linear function, I should say, right?
Yeah.
But what if x was 4? What is f of x? What is f of 4? What if I put a 4 in for x?
It'd be
You would get 3
0
over 4
undefined.
minus 4, which is 3 over 0, which is
Undefined.
undefined. So for this function right here, The range is everything except when x is 4. When x is 4, this function cannot exist. Okay? So that's why you might have a gap. Because there are functions that aren't true. Here's another function that could not ever happen because it can't be true. You can't take the square root of a negative number, ever.
Because you can't times two
That-
things together and get a
Exactly. That would have a range. This would have like no range. This cannot exist. Okay? So you have to be careful about those.
Okay, so you know that thing we were talking about last time? My idea that I was thinking
Yes?
doesn't work.
Okay.
But I did find the way to
Good.
put points that's super easy.
Glad you did it. Yes.
So,
Well, yes, and they were right here. Yeah. Okay? Okay, so what I want to do right now is there's way more in this lesson, but I want you to practice that part right now. We can practice the first one together. Okay? Practice the first one together. We have 3 different things happening now. Oh my, that's scary, right? Okay, so what do you think the first step should be?
find the points of all those.
Okay, so how do I do that?
It's
Well,
the
on the 2,
it's the one that's farthest to the right.
on the 2, it crosses the Y.
No. On the
Okay.
0 it crosses the Y.
Okay, Kara
Y
is doing one thing. Kara's finding the y-intercept.
Wait.
Yeah.
Kara, you found the y-intercept and you're right.
Oh.
And Alex is finding a point. And he's right. Okay? So Kara just looked at this and goes, well, I know where this crosses the y-axis at 2. Right? And it does. Alex said, I'm going to find what f of 0 is. I'm going to put 0 in there. And 0 plus 2 is 2. So I know the point 0, 2 needs to be graphed, which is the exact same point Kara had. Okay? Is it opened or a dot? Is it a circle or a dot?
It's a circle.
It's a circle, right? Okay. The things that are graphed are going which way from this?
Down. Or to the
To
Negative
the
side.
left. To
Yeah.
the left of this, right? So from here, I can do my slope, which is what?
1. Well, 1.
Negative
Negative 1
1
minus
over negative.
negative 1.
Okay, it's positive 1 over positive 1, but that doesn't help me, right? So if I go negative 1 over negative 1, this helps me. Negative 1 over negative 1, negative 1 over negative 1. I got enough to go by. Okay, here I go. What about next?
Now we have to do that for the next problem.
Now for the next problem. Oh, what the heck does this mean?
That's
You
a
have
good
to-
question.
Do you have to like rip it or something?
No.
That means you're gonna have a short slot of the line, but it won't fall on the graph because the graph's not big enough.
This means, to say it in English, this means this stuff is happening between 0 and 2. So I'm only going to graph this stuff between 0 and 2. You're only going to see this part of the graph right there. Because this is 0 and this is 2. So I'm only going to see this graph, a little tiny piece of this graph right here. Okay? Now, it's going to be hard to find a point there. I don't know what to put in there. I don't know if I should put in, maybe I should put in 2? I don't know.
Well, couldn't you just like make that first part y equals that and then graph those points?
Yep, you can just graph it like a y-intercept. We got a y-intercept, don't we?
Yeah.
Which is 5, right?
Yeah.
We got a y-intercept, which is 5, which I'm just gonna put 2 in here because I've already put 0 in this one, right? I'm gonna put 2 in it and see what happens. So if I put a 2 right there, I would get 4 plus 5, which is 9, and I would need to graph the point 2, 9, and that's not going to be on my graph, is it? Okay, so maybe I'll just do the y-intercept one. So can I find the y-intercept at?
It's It said 5.
5. So 1, 2, 3, 4, 5. Is it going to be a circle or a dot?
Dot.
Circle.
A dot.
Dot. Yeah, dot.
It's going to be a dot. And what is the slope of this line?
Plus 2 over plus
2
1.
over 1, which isn't going to help me any because I
No.
can't go up 2 and over 1.
But you can go.
Down to.
Which is the same thing as down 2 and to the left 1, right? So I can go down 2. Oh, left 1. Down 2 and to the left 1. This isn't going to help me either, really.
Why not?
Well, because my graph needs to be between
0 and 2.
0 and 2, and I'm going to the left of that. Okay? So it's going to be off of my chart. David did a disservice. So we're going to go up 2 and pretend, and over 1, and up 2 and over 1 anyway. Okay? And I'm going to stop right there because that is 2. That's it. That's all I can graph right there. That's it.
So it's just going to be that little.
It's just going to be this little short thing right there.
And is that point over there going to have a dot?
They will have dots because both of these have equal signs. So I have dots on both ends.
What would happen if one of them was less than or equal to and one of them was less than?
One will be a dot and one will be a circle.
How do you know which one?
Because at 2, it equals. So at 2, this would be an equals. If this
Okay.
didn't have it here, it would be open.
Okay, gotcha.
Okay? All right, and the last one, can I just use slope-intercept form here and get along fine?
Yeah.
Well, maybe not, though.
Oh, because it's negative x.
Well,
Well, no, that doesn't
it's
matter.
still going to work, but this would tell me where my line started. If I would just put a 2 in there, this would tell me where my line started. So if this was a negative 2 plus 1, that would be at negative 1. So if this would be 2, negative 1 would be the point where it's going to start, which I kind of like that. Because if I did slope-intercept, I'd be over here, wouldn't I? And I don't want to graph anything in there. So 2, negative 1 is where it's going to start, and is it going to be a dot or a circle?
Circle.
A circle. And from there, I can do my slope,
Negative 1 over 1.
which is negative 1 over positive 1, or positive 1 over negative 1. And since this stuff is greater than 2, I want to go this way. I'm probably going to go the
Down.
minus plus, right? Minus, plus, minus, plus. And I'm only going to graph this much of it.
Yeah.
Mhm.
I'm looking at the next one. and
Sure.
I'm lost.
So, wait, we got to do domain and range. Domain. Leftness.
All real numbers.
Infinity is leftness. Does it go infinitely to the left?
Yeah.
Does it go infinitely to the right?
Yes.
Yeah.
Are there any gaps?
No.
When you squeeze it in there,
No.
do you see a graph everywhere?
Yes.
Yes, you do. Okay, so the domain is all real numbers.
This one's not range.
Your range.
There's a dot. I mean, there's a space.
Does it go infinitely high?
Yes. Well, from a certain point, yeah.
No. This is not infinite. This is a dot,
Oh, yeah.
right?
Oh.
It stopped there, right?
But
Yeah.
that bottom one
This
is
is
a
not
line.
infinite.
Okay.
Does it go infinitely low
Yeah, after.
after a certain point, right?
Right.
So, first of all, my graph does not exist above this point at all, does it?
No.
It stops right there. So we have to think of all the things that it does before I write this out. It's lower than this point, which I don't even know what this point would be. It's 9, isn't it?
Mm-hmm.
It's lower than 9.
Wait.
Because remember when we did put 2 in there, we got 9. So we got 2, 9 as a
It
point.
should be 1, 7.
1, 7 is also a point. But 2, 9 is where this exists. Okay. At 2,
Oh, yeah.
At 2, this is 9. So this is the point 29.
Right.
Okay? So it's lower than 9. It doesn't go any higher than 9. It's below this line. It exists everywhere, doesn't it? I mean, even between here and here, it exists, right? There's something there.
So it's going to be less than
So it's okay as long as it's less than, what is this line?
2.
2. So less than 2 is okay. It's less than 2. But in between 9 and 2, I have a little gap.
Yep.
The gap occurs
So will your range be less than 2?
here. So no.
no. 'Cause
This
you-
is how you're going to write this, okay?
it'll be something
This is
in.
what I'm going to write. I'm going to write the set of all f of x such that f of x is less than 2, because I'm okay as long as it's less than 2. Okay. Or, okay, now this one's weird, so don't start it out yet. Or that it's between here and here, right? That's the only place it exists. It exists lower than here or between here. Correct?
Yep.
So the lowest end of this
5.
is 5, and the upper end of this is 9, and it equals both of those, so that's where we sit.
Oh my god.
I
I'm
believe
dead.
that. No.
Do you want to keep these?
We'll do some more.
Remember?
Yeah, we'll finish them tomorrow. I don't like babysitting your papers, but I will. Turn my recording off before I forget.
How much time?